Right, let's start. So thank you for coming all the way to the third floor, because observability is a very advanced topic, and I got to sit very high up to get that view of the land. We call this a 10,000 feet single pane of glass view, right? Those that have been doing observability. And it's a new field for data and AI. Many of the data practitioners, analysts, engineers, scientists, they're used to notebooks, they're used to dashboards. They're not really used to things like New Relic, Cup Dynamics, Dynatrace, Azure Monitor, GCP operations, CloudWatch, and AWS, right? It's an SRE DevOps culture that's just starting because the Lakehouse apps that you've heard about are just starting to emerge. And so the critical, mission critical expectations on SLOs and data quality are only beginning to be very real for businesses. So today I'll talk about how we're approaching this. A year ago, we had no talk about this. And so customers have been asking again and again. We had really nothing to comment on other than we're working on it. And so now we have built something over the past 12 months, and I want to validate this with you. And so for those who came early, you fill this out. If you haven't, it's a quick survey, 3 questions only. You don't have to fill out the second section. We basically want to measure how you experience in today simplicity of tracking costs in Databricks, simplicity of tracking compute utilization, and simplicity of tracking what your users are actually doing, activities, events within Databricks. Be truthful. Tell us how it is. Hopefully, at the end of the session, we'll ask you to do this again. Your opinion may change, but we'll see. If it doesn't, then I'll want to know why. And so just a call out, everything we're talking about here is informational purpose only. Some of the things I'll show you are still being worked on. This is public preview. Some of the things I'll mention are private preview. If you want to sign up, come to me afterwards. I'll hook you up. So we're still working on the observability story. And so why am I qualified to talk about this? I've spent 20 years of my life at Microsoft. 15 of those I've built observability for Windows, for Power BI, and for Azure. So I built the Promise Analyzer when we were fixing the slow Windows Vista and made it fast 7. I've helped teams like Xbox, Office to go much faster in Windows 8 and 10 timeframe. I then worked on Power BI from the ground up when it was still Power View, made it into what it is. It's a pretty snappy experience today. And then went to DevDiff and Azure to build application insights inside Azure Monitor. So if you work in Azure, I've touched many of the things inside Azure. I even wrote a book on perf analysis. So my roots are actually in development. I was a software engineer the very first 5 years of my career, and that's what taught me that observability is a must-have before there was a term observability, because we had to do end-to-end system-level visibility in Windows. So what is observability? It's many different things. I've been talking to Expo folks, especially the vendors who claim they're observability vendors, but everyone has a different definition. Succinctly, in sort of TLDR, it's quality management through operational intelligence. It's everything you need to know as an operator. If you're operating a business and it's something that can cause that business to be misbehaving, you should know about it. So it could be many, many things. But it's always following the same sequence. It's always the what happened, when did it happen? This is the detect phase. Then who should be looking at this? Where is it broken? Or who was impacted? And which region was it broken in, right? And then the why is going to be the diagnosis. We call this root cause analysis. So it's historical, and that's the key thing about observability. People claim that their products are observable because you can call APIs, and so they call this API scraping. Yes, you can, but unless you remember the timestamp, put this in some log analytics database, it's going to be all lost. So observability is really a log analytics workload. And so historical, triage, and diagnosis are the 3 sequences. It's detect, triage, diagnose. And the close analogy is if you go to ER, if something happens to you, they do exactly the same thing. There is a generalist and then a specialist, and they capture what happened at the time of the incident. It's actually a really big industry. If you look outside of the data and AI space, it's today at around 8 billion, depending who you ask. It's growing very healthy. In the web services, this is must-have. You cannot run today a business without observability. 10 years ago, that was still just emerging. These new companies were just emerging, but today that's a must-have. In this space, it is emerging today. In 10 years, this will be the same thing. Maybe even faster, because we're going much faster. Of course, it being a data and AI problem, we want Databricks to help solve this problem. And so today I'll show you how we're approaching this. But before that, how many of you understand the difference between monitoring and observability? Raise of hands. Okay, so let's talk about this. So monitoring is something that was there with us since the beginning. since the day one, since the box product, since every one of us was writing little code, right? Somewhere in a sandbox in a PC, because you had to emit something to see what was going on. So you had predefined metrics. Observability wasn't possible until very recently with big data transformation. Why do I say that? The amount of data that required for observability is insane. You cannot actually do this on a single machine. So monitoring tracks specific predefined metrics. So think Grafana, think StatsD. You take logs or metrics, you shove them somewhere. You know exactly what you want to send out, and that's it. And then people will build a dashboard on top and track that. Maybe they'll set up an alert. It offers sometimes a curated UX, so you will see monitoring experiences that will guide you through, hey, you should care about this. It broke. Look here, right? That kind of experience. And it's important, especially for people who are not experts, not SRE DevOps persona, who don't always look at these things. It's important to guide them through, and so that's monitoring. We do have monitoring. There's an entire session on this, on data quality monitoring. This is not it. This is next level. So what do I mean by next level? Observability recognizes that it's a vast space of metrics that you really need. It goes well beyond the few metrics that you could put in the UI in a monitoring product. And you actually don't know what questions you're going to ask. The questions will arise as incidents occur. So all of your metrics are latent compute. You cannot pre-compute them all because it's too expensive. You have to compute them when you ask the questions. And we'll see many of those different questions when I do demos. But it's going to be pre-aggregations on different time ranges, on different data sets, on different pivots and dimensions, right? It's all going to be just data and AI problems that you all already do anyway, just not in the space of observing your product. And so it covers a much, much broader set of use cases that goes well beyond what typical metrics do around, say, SLO, service level objectives. And so what we call this jobs to be done, JDBDs, in observability? What do people really care about? The number one class of or category of issues is ability to promptly resolve operational incidents. Basically, be ready for anything that happens. You cannot do this with monitoring because you don't know what's going to happen. You don't know what you don't know. And your code continuously evolves. Your upstream dependencies continuously evolve. Your underlying dependencies on the platform continuously evolve. You may move a cloud. You just don't know what you don't know. And could be workloads failing. Could be runaway workloads that should have finished but did not. Could be some data incidents because your data got exfiltrated or got polluted upstream, and now you need to know who got impacted, right? All of these are incidents you need to react to as an operator. But you also need to effectively plan ahead, and that's also observability. You need to be able to forecast so that you have low incident operations, so you don't continuously fire drill, because that's no way to run a business. And so that includes capacity planning. How many cores will I need? What types of compute? In which regions? It includes budget planning. How much do I expect to spend over the next quarter or two? I'm actually going to show you today AI-powered dashboard that helps you do that. And then usage analytics. Who is doing what? What are the best practices? Should I promote something through excellence that this team is doing to the rest of the teams? Are we even using ML? How much are we using ML, et cetera? These kind of questions. So Matej announced Lakehouse monitoring observability at Keynote yesterday. I'm going to try and unpack this for you today because that was like 14 seconds of glory for us. But he has only 14 minutes, so he has to slice it through all the Unity Catalog announcements. And that was the slide. There's two dashboards. I'm going to talk about the second one, the more interesting one for you. So first of all, you see is governance. And governance is two things. It's controls and observability, which means I need to be able to enforce, and I need to be able to make sure that I have enforced. Right? I need to actually see what's going on. And up until now, it was very heavy on controls and pretty light on observability. We didn't really have much of a unified story. You could do all of the things I'm going to show you today, but it's going to require you job API scraping, log file ingestion into a third-party log analytics solution and metric analytics solution. So it's a full-time job for a team to be able to answer questions that I'll show you how to do yourself with SQL and Python. And so I'm going to be talking about this section of one of the 4 pillars that we now have an updated landing page for Unity Catalog, which is gain comprehensive Lakehouse observability into your data and AI with operational intelligence, utilizing, and this is keyword, built-in system tables for billing, audit, lineage. We'll talk about what system tables are, but most importantly, what the data that feeds into those tables is. We also published a blog also yesterday, what's new in Unity Catalog. One of the sections talks about Lakehouse observability. So I'm not going to drain the slide, but basically we're announcing public preview system tables. It's ungated, available to everyone. We've been running this for 4 months in private preview. Had about 100+ customers. Many partners already started migrating over. Some of our partners are making announcements at the summit about building new functionality on things like lineage audit system tables. There are two namespaces, schemas, databases, whatever you want to call them. System.access contains audit and lineage analytics data, and system.billing contains cost analytics data. We have entire sessions on each of those. So folks in the room, Greg in there, will do a session today on cost management, and we'll mention cost analytics. And then Mengley, who was just here, but he ran out because his wife is about to give birth. But that's how he's dedicated to this effort. He owns the lineage, and so he gave a talk. You can watch the recording yesterday in the PM on the lineage cost analytics. We also announced that it's a centralized analytical store. And so what that really means is unified operational data plane. All of the operational data now sits in one place, and that's super important. If you look at every cloud provider, they've done this maybe 5 years ago. Azure Monitor, GCP Operations, which is BigQuery, and AWS has OpenSearch CloudWatch, right? So they put everything in one place because they have acknowledged that there is no way to answer these questions in operations unless everything is in one place. I need to join. I need to connect the dots. And it's enterprise grade, and it's ready for all the product lines at Databricks to emit more data. So this is just a start. I'll talk about other things coming online. But the key challenge was to actually get this in a state where all of you can query, and the data is going to be kosher. It's actually going to be healthy every single day, 99.99% SRE DevOps, expected reliability, availability, latency, et cetera, data guarantee. So that is now in there. And that's what we spent the last year building. And you can query this using anything in Lakehouse. And that's a new thing for observability. That's actually why I came to Databricks from Microsoft, is because at Microsoft, I've kept trying to build a perfect APM. App Insights was almost perfect, but didn't have any AI, right? There was no artificial intelligence. And for me to hook up AI, I would have to go to Azure ML team and to the Synapse team and to the Fabric team and connect them all together and bolt on some Power BI on top. And that's still not as good as I can do it in Lakehouse. So Databricks lets you put everything in one place, data and AI, and lets you run, as you'll see, Python, ML, profit forecasting, and then SQL, DB SQL on top, and dashboarding, and notebooks. And if you want to do Power BI afterwards, I can show you. It's very easy, direct query. Tableau, very easy, direct query. So solve all of your problems directly in Lakehouse first. It's funny how people take data, observability data, out of Lakehouse. They build dashboards on it, and then they say, hey, I want to do anomaly detection. I want to do baseline detection deviations. I want to do AI, forecasting. And for that, they bring it back to Lakehouse. So you just paid for extracting the data, which is in petabytes. You paid for the service of building dashboards and visualization. Now you bring it back for analysis. Makes no sense. Make your analytics first in Lakehouse, and then you can do whatever it is you want. So meet Adam. Adam is the admin through 2022, which is last year. For many of you, that's probably still true up until today. Hopefully, tomorrow you will wake up a reimagined Lakehouse admin. And so admin was promised a great Lakehouse, right? But then he went and tried to do account administration and found audit JSON files he has to download to cloud storage and parse through those. Everything is there. Knock yourself out, right? Billing admin, he wants to track costs. Well, it's another file. It's a CSV file. Different way to deliver or consume. Again, knock yourself out. Parse through all of those weird JSON properties or CSV bags. Let us know how it goes. And then he has to go and manage compute because his CDO is saying, hey, we're spending too much. Are we over-provisioned, under-provisioned? So he goes to Gangle, and it's a PNG. So there is no historical. While the cluster is running, you can capture a screenshot. Put this somewhere in your SharePoint. Workspace admin, API scraping. So it quickly goes down the road there. So this will take a while for Adam. And so Adam has a really poor boat to get around Lakehouse, right? How many of you feel this is true today for you? Oh, that's a lot more hands. Good. You're in the right room. So we spent the past 18 months working on this. You don't want to be that penguin. So this is the world of Lakehouse Observability today. It's a whole bunch of different stacks for different personas not talking to each other. It's organic in nature. It just came out of how it was built. But it's three things. It's inconsistent data sources, which is everyone uses different language. Disconnected data, so they talk past each other. There's no way to join. And it's data gaps. It's not comprehensive. It's not telling you the full story. And so this is sort of the dark, advanced enterprise slide that I stole from the keynote. But it's basically pre-Unity catalog. We couldn't fix this, really. Everyone was asking questions, but there was no unified platform for us to fix it with. Because that kind of data requires governance, again. UC is also used for governing operational data within Lakehouse. And so the way we're fixing this is we are putting system tables managed by Unity Catalog. When you onboard Unity Catalog, you get access to all of your operational data. It's not only the data from the UC managed workspaces, it's all of your data. So if you today don't use Unity Catalog, you can still onboard a single workspace, light it up with UC, and get access to all of your data directly in tables in Delta, and do all the things you already know how to do with data. That's what it looks like. So back to the observable sort of white background. That's what it really looks like. It's a bunch of data sources across Databricks. Every product line has their own, and there are different ways of how they push the data out. That's just implementation details. But what matters is that all of this lands as data inside tables. So it's fact tables and dimension tables. We start at bronze, which is raw data optimized for storage. And then it's all, of course, normalized. And then we start enriching it so it's easier and easier to query so that you can actually build effective dashboards. And I'll show you a few examples of that today. From that, you can start building insights. Everyone in your organization, no matter what the persona is, uses the same tools. You only train them once. They all can speak the same language. They can share links. It's the collaborative experience that observability in web services has been having for the past 5 to 10 years, depending on how mature you are. And you see managed, Delta Lake-backed, DB SQL, Python queryable, all of those things. So consistent, connected, and comprehensive are the 3 requirements we put on system tables, and we call them the API, the observability API of Lakehouse. We're saying, hey, instead of you scraping jobs, which is an API, how about we just put this, since it's data, in Delta Lake, and we enforce the same kind of guarantees we enforce on APIs, so you can build mission-critical analytics on top, so that partners can build products on top. There are many more coming. Billing, audit, and tables, columns, lineage are the dark green. Those are the ones in public preview. Some of these other ones are in flight. I'll show you another view afterwards at various stages. So you should see more coming up in July, August, September. It's a pipeline. We're ramping up every product line to emit continuously operation telemetry. And it's, of course, across clouds. So the Adam's world in 2023 is much better. He now has dashboards directly in Lakehouse, notebooks. He actually feels like he's in a good spot, and he's got a good boat to run around. But it's still not perfect, because he's going to be the account admin, and the MetaStore admin, and the catalog admin, and the workspace admin, and the billing admin, right? So there's a lot of jobs, a lot of hats to wear. And so the way you get around this is 2 things. You leverage AI, right? You've heard about Lakehouse IQ announcements and whatnot, but like just a basic AI of forecasting you can now do. You don't have to go and buy complicated, expensive tools, because you're in Lakehouse. All the data is in Lakehouse. We'll give you a package that you can run on your account today doing exactly this. I'll show you a demo of this. So that saves time, right? And it will give you sort of at a glance spend, last month, next month, forecast, 6 months out, 6 months trailing. It'll give you the upper lower bounds. You'll be able to alert when you exceed the bound. Why is that interesting? Well, what is it? If there is a runaway job, you want to stop it as soon as possible, right? You didn't expect to be spending so much. People should take a look. You will be able to assess utility. Are you writing to tables that you're not reading from? Are you writing to volumes, paths you're not reading from? And map it to dollars. Because the best you could have done before was DBUs, and DBUs mean very little to your CDO. You need to multiply by the list price, or whatever price you have. And you'll be able to track things like usage of different data assets. So we're giving you basically the glasses to make the data connect to what you need it to be for your execs to feel good about running on top of Lakehouse. So the second thing other than AI is divide and conquer. Adam cannot possibly run a business single-handedly when you have 800 workspaces. Just doesn't work, right? So you gotta divide responsibilities. And so the way you delegate is there are different people doing different roles, and each of them has different scope. Since we use Unity Catalog to manage access to system tables, you can grant different access permissions to different personas. And so someone will only have workspace level scope, someone will have MetaStore, someone will only be able to look at the billing table, nothing else, etc. Because maybe your discounted pricing is privileged information, and only that person should have access. But there are also all of these other folks, and sometimes they have to self-admin. Increasingly, they have to self-admin, because there are ML endpoints, SQL Server endpoints, DLT pipelines, workflows. It'd be nice if all of them could just self-serve and not always run to the central team. They can, again, with system tables and UC. So our vision really is we want to enable the best Lakehouse observability. This is no different than any other cloud provider. We think of ourselves as a cloud provider. We're not sort of big enough. And that means many things. It doesn't mean we're going to go and build the best observability APM tool and kill all the competition. That's actually not the point. We want all the partners continuing to build observability tools on top of the platform that's now robust and reliable, because the previous foundation was very shaky. APIs, we hit so much, we're rate limiting them, which means you drop data, which means what you see is not what actually happens. So we want to avoid that and give you the right data the right way. We also don't think it's a problem. We think it's a workload. In the Lakehouse universe, observability is just another data and AI workload like healthcare, retail, right? You just reason on top of it. And we think this is going to help accelerate adoption across all customers, all personas, all clouds, because we're going to have a multi-cloud experience that's very unified, no matter whether you're in GCP or Azure or AWS, or if you run across all of them, we have customers like that. You're going to have a single consumption experience for all of your Lakehouse assets. And so we've done our homework. This is not just a hypothesis. Like I said, we ran a private preview, about 150 applicants. We accepted about half of them based on our criteria and had very high engagement throughout the 4 months. So 42% are admins, but then there's all of these other personas, DEs, data engineer, data analysts, and data scientists who also need access to observability today. And that's just a private sort of preview. I'm expecting those to shift significantly out of admin into the other personas as we go broad. Private previews are skewed because admins usually come to us crying. And then across clouds, we're shipping AWS and Azure, and GCP is coming very soon. Optimistic end of year, realistic beginning of next year. We got some catching up to do there. You also, like I said, don't have to be on UC. Only half of our private preview was on UC. The rest were still onboarding. And that's a great, if you haven't onboarded to UC yet, that's how you onboard. You just enable one workspace, you play with it with operational data, you see the value, and then you can convince your CDO, hey, this is actually good, we should probably migrate. How many of you know what log analytics is as a product? Okay. So log analytics, the observability revolution going to services and the cloud gave rise to whole new types of markets. One of them was log analytics, which is take petabytes of logs, unstructured, semi-structured, and make sense of them, right? Build dashboards, latent compute on top of huge amounts of data, which is what you can do in Lakehouse, but you can do this in Splunk, in KQL, in Elasticsearch, et cetera, right? Observability proper is logs, metrics, and traces, which is I want to have log analytics, latent compute. I want to have metric analytics to be cost-effective, pre-computed for some specific things, and to do very fast alerting. And I want tracing that connects the dots on everything, so it correlates to the business transaction. We are leading with log analytics because that's where we're the strongest right now. So you see Delta sharing, you see in DB SQL Python. The big difference from every other log analytics solution on the planet right now is it's not just SQL or just KQL. You can do so much more when you have the full power of Lakehouse. I'll show you this today. So making it simple, of course, is the number one goal for us. And we're going to give you a toggle, so you don't have to be very advanced if you come to Lakehouse and want to get your logs. You'll see a table. I'll actually show you those tables, and you'll be able to just do a query. The quickest way to get to operational data is going to take you a minute if you're an admin. A bit longer if you're not admin because you have to get permissions. But of course, at scale, you want to be able to enable this on your 800 workspaces, right, across multiple regions. So there is UC API. You can do command line with curl. You can do notebook like this. It's all in the docs. Docs went live this week. You can even do Postman. If you've played with REST APIs, there is a UI that lets you call APIs in REST. All of these things work. But we advise Terraform. Terraform is probably the most effective way to just do this once and forget about it. So let's keep going. This is the stats from our private preview. Like I said, we had about 150 customers. And that's what they've been asking for. Because, again, observability is many different things, right? But what do you really need? What should we focus on? So at the very top, you see billing and audit. People just want to know how much are they spending where, who is using what, accessing what, where is the data being exfiltrated, and also want to get the full lineage. And that's exactly what we brought to public preview. The other things are all in the works, and you'll see them throughout the year coming out into public preview as well. Some of them will be in private preview as soon as a month from now. So if you're interested, then stay afterwards, and we can hook you up. Now that I've talked about system tables, it's just a slide to give you the full formal sort of dry definition of system tables. It's Delta-backed, DB SQL Python queryable, UC governed, account console managed, notebook consumable. And we're starting with 1 hour P99 data freshness, but you'll see things like lineage already run in minutes. So your data freshness is already in minutes in some cases, and we are working towards 5-minute P99 with an internal SLO that we run as an SRE organization. There's a dedicated team running the pipelines for the platform system tables. Our vision, the North Star, is 5 minutes to wow, which is you come to Lakehouse, you never have to stand up any compute, it's all serverless. You did anything with the Lakehouse, there's a dashboard that shows you what's going on based on system tables. So I've talked quite a bit. Let me show you a bit of demos. So you know this is real. First of all, these are the actual, how hard is it to see for you? I guess it's a room, not all good? Okay, perfect. So these are the tables. Access has audit, column, lineage. You can play with this today. It's ungated. All you have to do is opt in. So go to the docs and opt in. And we will start exposing this in your meta store. Why do you need to opt in? It's a delta share. For us to offer this low level of latency, the logs have already been in the system. They're required for us to run the business. We're just sharing them with you now. And we clean them up so that they are in a form that actually makes sense, connected, consistent, comprehensive. So you have access to all of those things. Here is a typical notebook that you would build if you say wanted to analyze job costs, right? So, and this is probably closer to the data science people than the data analysts because they will be sitting in SQL. But it can get you things like, this is a very long, by the way, table that we're going to put as a system table. It's pricing. It's mapping SKUs to list prices. You will not have to build this maybe in a month or two. But it lets you track who is using what, sort of number of jobs, owners, workspaces, and maybe what's the week over week DBU percentage change. So I can go and look at the spike like this saying, that's not good. We seem to be spending a lot more than we did last week. What happened, right? It can do things like, let me call out who is the highest change in weekly dollar DBUs by workspace, right? You can ask analytical questions. You can quickly start appreciating that these questions are not possible to build in a curated UI because they will be very custom to very different use cases, and you're going to drill with more and more questions. And of course, in the end, you will settle on some of these questions. This is statistical spread on your most expensive jobs, right? Like look at the top 10 and just show me how much do they deviate, right? But then you'll go and build a dashboard. You'll just pin them to a dashboard. You'll call this job cost analysis. Your team will operate on this, maybe in a daily stand-up or weekly stand-up, depending on how you run your business. And you'll just track, hey, my most expensive workspaces, these ones. Who are the highest spenders, right? And you'll align the timelines, and you'll be able to see when I spiked what happened. So this kind of views. And that's a very naive way to do observability, but that's what most people do today. Almost in every single product in observability, I mean, there is no really AI there, unless the vendor builds some anomaly detection into a learning. So that's really all you have to do with the data is you track it, you still monitor it, it's just that you write different queries to monitor it. The only thing that's changed is now latent compute. We think we can take it much, much further than that. So let me back to the slide. We will share the deck. You can watch the video if you want offline. I'm going to skip for the interest of time. We think that SQL, which is what all of these queries were built on, is the last mile language for observability. It's way too complex to express in SQL observability queries because there are so many joins. There are so many aggregates. There are so many calculated columns. And that's why I wasn't diving into those SQL queries, because they are complex. You actually don't want to be doing this. You want to build these gold tables, or the bronze tables that make SQL easy. And we think that building gold tables should be done in possibly other languages like Python using AI. And really, now that you know about Lakehouse IQ, we think English is the last mile language. So increasingly, you'll just have everyone, not just analysts who know SQL really well, but the engineers who don't, or the scientists who are sort of on the fence because they're mostly Python, be able to ask the same questions. And we think that to extract intelligence, you really need AI. We are drowning in data in observability. Even if you think that you found the problem, oftentimes AI will tell you no. When you do it at scale enough, you will find out that's actually not that needle in the haystack. It's other thing. There is a name for this. It's called AI Ops. I'm yet to see a product in the industry that actually does this. Everyone claims to do it. Some people even call themselves AI Ops, but no one has really solved that yet. So the ChatGPT moment hasn't come for observability yet. But we think with Lakehouse it can. So this is what we think should look like. You start with the data science. You're in notebooks, and you maybe forecast your spend on ML. and you see a rise, right? And you can ask it to forecast 6 months out based on 12 months previous, and to alert when it goes and exceeds. Because 3 times in a row you were true. I know this is really hard to see, but these 3 things are true, true, true versus false. Every time we check whether you exceed or don't exceed upper bound. And if it happens in a row, we should notify the admin. And then we can build these kind of things. And then we can build these kind of things. Let me actually show you this in practice. So it looks like this. This is a real dashboard. We ran this on our staging data. It's one of our environments we use. And so you can quickly at a glance see how much are we spending month to month. The numbers are a bit bogus because this is list prices. We don't pay ourselves list prices. But this is what a typical use case would be like, right? And so a mid-range enterprise spending this kind of money definitely needs this kind of single pane of glass. There's just too much data, too many things going on. For us, it's just one of the environments. We have many more. This is the total DBU spend. So it's looking at the last 12 months, and it's predicting the next 6 months. So you're able to do semi-annual budgeting conversations now backed by AI, and not just guesstimates of sort of, let's just do a line and see where it goes. We do this by forecasting every SKU separately. So you can see the rise of ML that started with ChatGPT phenomena. Everyone all of a sudden is now investing in ML. And so that curve started forecasting long before this session. It was going up a month ago. It was going up 2 months ago. And so we know where we should be if the trend continues. In fact, it seems to be expanding because there's some uncertainty. And then the total just aggregates across all the SKU forecasts. So it forecasts every SKU independently and then aggregates. This is the lineage I was showing you that's showing you, am I spending healthy or unhealthy? This is on tables. This is on paths, volumes. Volumes is a new thing, so people keep writing, don't read from. In this environment, we stress testing. You can build all of these things today. Some of them are like this, backed by a SQL query. If you want to know more about this, watch the lineage conversation. That's just SQL. That's easy. But some of them are a lot more complex to run, like this. And so when you look at the query, you're not going to find much. It's like a single line, because it's a goal table. And the goal table is produced by something else. So what is that something else? It's a Python notebook that we've scheduled as a job to run 6 a.m. Pacific time every day. You can actually see the job. It runs every day. And it looks at the last 12 months and does a forecast for the next 6 months by SKU and an aggregate. Right? So it's a whole bunch of Python code. You would go to your data science team. By the way, we're going to give you all this code. So you can go and have them review this, productize it in your environment, and get that kind of a dashboard running. So now that you have observability and you see what's going on, you don't want to be looking at dashboards all the time, right? Some people build great observability tools, but then they miss the last mile, which is, I don't want to have a human continuously observe it. I need some integration with alerting, ICM, right? And so they build what they call EMS, email messaging system. And so you get spammed with 1,000 emails, and you put them all as an auto rule to trash, and no one ever looks at it. That doesn't work. In production, you have to have production level alerts. But so before that, there is a static alerting demo. How many of you know about alerts in Databricks, in DB SQL? Okay, let me quickly play this back.
Hi, today we're going to walk through a quick example for how to alert on system tables in Databricks. In this particular example, we're going to alert on budget utilization. For instance, if we've spent over 95% of our monthly budget to date, that's something we might want to alert on. How do we do this? Well, we're in our SQL editor in DB SQL, and first we'll break down this query. So this part of the query is querying the system.billing.usage table for data and events that occurred within this past month. It's grouping the total DBU usage by SKU and then summing that usage. And you can see here per SKU what the DBU usage was. Great. The next thing we need to do is we need to get a dollar DBUs, right? This is only regular DBUs. To do so, we'll join it with a pricing table. Now it's important to note that pricing tables aren't yet available in system tables today, but they are coming soon. After joining it with this pricing table, we'll simply multiply the DBUs by the list price, and then we'll divide it by 400,000, which we've set as our monthly budget. And we'll call this budget utilization. So if we give this a run, we'll see that we've used up 74% of our budget this month to date. Awesome. Let's now go to create an alert. So To create an alert, we simply hit create alert. We name it. In this case, we'll call it a billing utilization budget alert. We can select the query that we just had. And then we want to make sure that we have the budget utilization column selected. Then the first row is greater than what we said was 95%. Awesome. We can set the refresh schedule. In this case, 1 day is probably sufficient. And then we'll create alert. Now we have our full alert set. To test it manually, we can click this refresh button. We'll wait for the query to execute. And we'll see the status is currently okay. Now by default, you'll be notified in your email whenever this triggers. But you can also add a Slack, Teams, webhook, PagerDuty destination, as well as external emails if you'd like. Thank you so much, and that's how you set up a basic alert on system tables at Databricks.
So TLDR is you can use Lakehouse DB SQL to set up alerts and integrate with your enterprise-grade ICMs. You don't have to do anything, sort of bolt things on the side. You can also run webhooks, which means you can run any custom code whatsoever, including self-healing. So if you wanted to shut something down, slow something down, throttle, you can do those things as well. So, but of course it's not going to meet the bar for production, let's put it this way. Setting static thresholds doesn't really work because your business keeps evolving, and so your thresholds keep evolving. And so I have another video. I'm not going to play it because we only have 3 minutes left, but we'll share this with you. How do you do dynamic alerts? The TLDR is, you saw that Python generating tables. It's going to use not a fixed constant. It's going to use a query to get that number. And so the number will change over time. We're going to forecast 6 months out based on 12 months trailing, and we're going to make sure that if you exceed more than, say, twice in a row above the upper bound forecast, someone should get notified. Could be Slack, could be PagerDuty, depending on the operations. And so you can try this yourself. What I just showed you is actually live. We'll put this in a DB demo. It's one of the 4 demos in Unity Catalog, and you can install this today. Would love for you to try it out and give us feedback. It is, I think, probably the best way to forecast. How many of you know what Overwatch is? Yes. How many of you like Overwatch? Okay, I mean, there is one. That's about the feedback I got out of the private preview, is that about 7% said it seems to work fine. So it depends on the use case. As you grow in scale, you'll find that Overwatch is not going to work for you. But what you probably don't know is that Overwatch is a cost management tool, open source. It's not actually a product in Databricks. It's built by Field. That is not ingesting billing tables at all. It's built on audit. So it's trying to predict based on what people are doing. And as a result, your numbers in Overwatch often don't match what the invoice is. So it's really dangerous ground, that shaky foundation you don't want to be standing on. This is built on the billable usage. So Greg there is our billing PM, the money PM. He doesn't have the hat today, but usually he runs with the hat and the mustache. And so he has a session later today to talk about cost management specifically. He'll dive more into the billing table. So just sort of a couple of testimonials. I only grabbed 2 because we don't have much time. Honeywell is an example that was on our private preview, and they were struggling with Overwatch. They actually also tried to do a third-party vendor solution. They tried to do DIY. They tried all different ways to try and fix their 150-plus workspaces observability for audit and cost. And in the end, they jumped on system tables. In 2 weeks, they had everything running. Before that, it was a nightmare. The other experience we captured was from Rec Room. They found that they had a zombie job running in test that they just copied from prod. In prod, it's supposed to be running all the time. Well, in test, you just want to test it and shut it down, but it was burning through money like crazy. It was in the sort of 50, 60,000 K range that they saved. So what's next? More tables, many more tables, many more in-product experiences where you can just do slicing and dicing without having to go to things like Power BI and Tableau. Those things are all coming. They're in private previews. If you're interested, again, stay afterwards, let me know. We can get you hooked up. And Lakehouse IQ, of course, because you got to use the right tool for the job. And Python ML will generate you insights much better than SQL. SQL doesn't know how. That means you got to use notebooks and workflows for that. But SQL is really awesome to detect. Once you've built that goal table, you can now run a simple query to build dashboards and alerts. And serverless works really well for these use cases because it's very sporadic that you have to do observability. So instead of keeping a cluster, running, which needs to be pretty beefy cluster to operate on these kind of data sets. You just rely on serverless when needed. And of course, you use English to ask questions in the end. Once you have all of this built out, Lakehouse IQ will figure out what these things mean. You'll be able to just talk to it in your organization. And if you're not technical enough, there are folks at Expo who can help you. There's a whole bunch of vendors who are building on this, and they will give you the curated experiences. If you don't have a big enough team to go and build your own dashboards, they will. Some other talks you should care about. So Lineage happened yesterday. Can't really go in the past, but there is a recording. Cost managing is 3:30 today. Greg will be talking. There was one on Tuesday as well that was talking about audit analytics on system tables. That was one of the tables I haven't really touched much on. And the SQL at scale is also going to mention how you do cost management for SQL using system tables as well. So now that you've heard me talk for the past hour, please fill out that survey again. Tell me if I changed your mind on these 3 questions. Is it now easier to track attribute cost for you to Databricks? Is it easier to manage compute utilization and visibility on activity and events? There is an optional section too. If you have the time, give us more context. We'll connect with you. It helps us slice the data. Thank you.